We have always been taught a comforting lie that has persisted for millennia, that the Great Pyramid was built by pure muscle power, by tens of thousands of slaves breaking their backs, hauling multi-ton stones up inclined ramps using primitive wooden pulleys and ropes. But here is the paradox that tears apart that illusion. To finish this structure in 20 years, as history records, the Egyptians had to quarry, transport, lift, and precisely place a 2.5-ton stone block every 3 minutes day and night, ceaselessly. Physically and logistically, such a feat is completely impossible with Bronze Age technology. In this video, we will decode a different reality, that they did not move mountains, but rather poured them from molds. Imagine standing amidst the Giza Plateau 1,500 years ago. Instead of hearing the screams of thousands of slaves or the harsh chiseling of copper against stone, you face an eerie silence. The air does not smell of forced labor's sweat, but faintly of alkali and evaporating minerals under the scorching North African heat. Before your eyes is not a chaotic construction site, but a massive industrial-scale chemical plant operating with disciplined precision. You look up at the blinding white limestone blocks. They are not being hauled up, they are being created right on the spot. This is when you must recalibrate your perception of technology. We often think high-tech means metal, circuit boards, and jet engines. But what if this civilization reached a different peak of materials science that we have overlooked? You see, the master craftsmen. Not men holding webs, but master chemists, molecular architects. They are not fighting against gravity, they are manipulating the state of matter. Instead of trying to lift a monolithic truck of stone 140 meters high, they carry it up in small buckets. At the tower's base, thousands of workers stir a thick, cloudy gray mixture in giant vats. It is Nile River mud. It involves crushed limestone, ash, and natron salt, a seemingly mundane mixture that conceals a sophisticated geochemical reaction within. You watch this flow of matter pass gently upward, poured into pre-shaped wooden molds right at the very top of the tower. Under the sun, this mixture fizzes slightly, releasing heat as atomic bonds form, restructuring from chaos into solid order. Have you ever wondered if impossible is just a word we use for a technology that we were never allowed to understand? In this scenario, the ancient Egyptians hacked into the source code of geology. They needed no giant pulleys or alien levitation beams. They used something more powerful, absolute mastery of geopolymer chemical bonds. They turned stone into water, transporting it as easily as the Nile. Then they turned it back into stone, eternal and immutable. This is the collapse of mechanical physics myths for liquid chemical physics. So, before you get comfortable, take a moment to like the video and subscribe, but only if you find this journey valuable. Let me know in the comments, where in the world are you observing this historical decoding from? Now, let's travel back in time. Let us deconstruct the story of a lost world, leave the scorching heat of Giza and step into the cold space of microscopic truth. To understand the scale of this technology, you must stop looking at mountains and start looking at dust particles under an electron microscope. When we place a pyramid casing stone sample under the microscope, the illusion of nature shatters immediately. You are looking at spectral analysis. If this were natural limestone formed over millions of years under the seabed, you would see absolute order, tightly compressed sediment layers, dense and uncompromising density. But instead, what do you see? Chaos. Observe this crystal structure closely. It is not sharp like cut stone. It has an amorphous form, resembling hardened glue rather than mountain rock. But the most damning evidence, the smoking gun of this geological case, is precisely those tiny black spots scattered everywhere on your skin screen. Air bubbles. In nature, under the pressure of millions of tons, limestone never contains such perfectly spherical air pockets. Air cannot exist under that geological pressure. Their presence indicates only one singular fact. This material was once in a liquid state. Imagine this process when a worker stirs concrete mortar in the 21st century. Air gets trapped inside the viscous mixture. When the mixture hardens, those air bubbles are locked away forever, a frozen timestamp. The great stone blocks of the pyramid are full of these air pockets. They are not stone cut from the mountainside. They are stone kneaded in the atmosphere, where air could penetrate the mixture and look even deeper into the organic components. In natural limestone, fossil shells are horizontally layered flat according to the laws of gravity, depositing over millennia. But in the pyramid sample, these tiny shells lie cluttered, random, rotated in every direction. Why? Because they were stirred. You are witnessing a molecular soup. It has been impacted by human hands. Someone scooped up wet limestone mud, overturned the order of nature, and poured it into molds. This is not erosion or plate tectonics. This is the sign of artificial intelligence in the most literal sense, an object created by intellect. Modern science calls this low-temperature crystal rearrangement. The ancient Egyptians might not have named it that, but they mastered this process. You realize these blocks are not just building materials, they are high-tech products, crafted with a chemical formula so precise that after 4,500 years, we are only beginning to suspect we were fooled by their rough appearance. You stand before the Nile, the lifeblood of this civilization. But look at this river through the eyes of a chemical engineer, not a poet. To the ancient Egyptians, this was not just irrigation water. It was a massive chemical repository. We are entering the reconstruction phase. Recreating the lost biopolymer alchemy. Forget modern cement kilns burning billions of tons of coal to reach 1,450 degrees Celsius. The technology you are witnessing here is much more sophisticated. It is a low-temperature reaction. Imagine dipping your hands into this viscous mixture. The main ingredient, Nile mud. It sounds mundane, but this mud is rich in kaolinite clay and aluminum silicate material, the backbone of geochemical reactions. But clay is just clay until it meets the catalyst, natron. You see the sacks of white salt being poured into vats. That is natron salt, found abundantly in dried desert lakes. We know Egyptians used it for mummification, to preserve human flesh forever. But here lies the paradox. The same salt used to harden biological tissues, when reacting with lime and water, triggers a powerful alkalization. When water is added, you need no fire. The chemical reaction generates its own heat. The mixture starts to warm up, steaming slightly. At the molecular level, a revolution happens. Weak mud bonds break, and atoms rearrange into an incredibly durable artificial mineral network. This is not concrete as we know it. Modern concrete is just sand grains stuck together by cement glue and decomposes after 100 years. This is reborn stone. This geopolymer technology creates covalent bonds exactly like natural rock in the Earth's crust. But it happens in hours, not millions of years. The result is synthetic limestone or granite, with a Mohs hardness higher than original material. You realize a shocking truth. The Egyptians were not just handy, they were masters of solid-state physics. They understood that to build something eternal, you cannot use mechanical force to coerce matter. You must persuade matter to change its very nature. They turned the rawest ingredients, mud and salt, into monuments that defy time. And frighteningly, they did it with energy efficiency and sustainability that our construction technology desperately chases. To find the manual for this giant machine, you must leave Giza and go up the Nile south to the granite island of Sel. Here, carved into natural rock, is the famine stele. For over a century, we read it as a tragic myth. 7 years of drought. The Nile did not rise, and Pharaoh Djoser prayed desperately to the god Khnum. But this is where you need to change your lens. Remove the glasses of a religious historian and put on the glasses of a materials engineer. When you do that, the prayer story vanishes. What remains is a technical blueprint. Look at the god Khnum described on the stele. Mythologically, he is a ram-headed god who created humanity on a potter's wheel. Why a potter's wheel? Why clay? The symbolic signal here screams a clear message. Khnum is the god of molding. He does not chisel life from hard stone, he molds it from soft matter. The most important part of this stele is not the lament about famine, but the god Khnum's response. He grants the pharaoh list. Traditional scholars translate it as names of precious stones and mystical places, but analyzed through geochemistry. This list, including ancient words like bekan, mat, yat, coincides chillingly with mineral ingredients needed for geopolymer reactions, ores containing arsenic, silicate minerals, and most importantly, natron. You are reading a recipe. The stele details how these materials are gathered, crushed, and mixed to build temples for the gods. This is not magic. This is an industrial-scale material procurement and processing procedure. Imhotep, the great architect credited with this knowledge, was not just a physician or priest. He appears before you as humanity's first brilliant chemist. Imagine the shock of this discovery. The Egyptians did not hide their technology. They carved it in stone for posterity to see. But over thousands of years, we lost the technical vocabulary to understand it. We see deities, while they speak of catalytic reactions. We see miracles, while they describe manufacturing processes. The famine stele is not a lament. It is a technology patent. It confirms the pharaoh's true power lay not in armies, but in controlling an advanced concrete, allowing them to cast artificial mountains at will. Under the patronage of a potter, God, the great chief engineer of the ancient world. Stand closer. You face one of the greatest architectural mysteries of all time, the razor blade test. Any tour guide will proudly tell you that these blocks fit so tightly you cannot insert a paper or razor blade between them, but pause and think like a mechanical engineer. To achieve zero-gap precision with Bronze Age chisels, workers must grind a 2.5-ton block surface with an error margin less than 1/10 millimeter. And they must do it not once, but millions of times, on all four sides, even with modern CNC laser cutters. Achieving the tolerance on this scale is a logistical nightmare, with copper hammers and chisels that violates logic, unless they never cut them. Reimagine the construction process through the geopolymer lens. You have a solidified stone block below. Its surface is naturally rough and uneven. Instead of spending weeks grinding the next block flat, Egyptian builders simply placed a wooden mold on top and poured liquid stone mixture in. What happens according to physics? Gravity does the rest. The fluid automatically flows into every crevice, every microscopic indentation of the block below. It self-levels and fills. When the mixture hardens, the upper block becomes a perfect negative copy of the block beneath it. That is why there are no gaps. You cannot insert paper between them because technically, there is no extra space. The two blocks touched at the atomic level from the moment the second block was born. This is liquid architecture. It explains why the pyramid still stands after thousands of years, despite earthquakes leveling modern cities or around Cairo, in a standard brick and mortar structure. Shaking cracks the weak points at joints. But here, stones lock together like organic Lego pieces when seismic waves pass through. The entire structure moves as a unified, flexible, yet unbreakable mass. The impossibility of precise stone cutting has vanished. Instead, you see a genius solution for efficiency. Why fight geometry when you can let liquid find its own path? The Egyptians did not try to conquer nature with forced perfection. They exploited the fluidity of matter to achieve natural perfection. If those giant blocks make you doubt muscle power, these tiny objects will make you completely lose faith in tools of that era. Go down to the Saqqara underground, where archaeologists found not 1 or 10, but over 40,000 stone vases and plates. Many are made from diorite, schist, and corundum, the hardest rocks on the planet, reaching 7 to 9 on the Mohs scale. For comparison, modern industrial steel only reaches about 7.5, and the tools of the Egyptians at that time, copper, hardness is only 3. You face a blatant violation of basic physics. A soft material cannot cut, drill, or abrade a material 3 times harder. Trying to carve diorite with copper is like trying to cut a glass sheet with a chocolate bar. It is absurd. That the strangeness does not stop at hardness. Pick up a vase. There are necks so narrow you cannot fit your little finger inside. Yet the body below bulges and is completely hollow. The walls are eggshell thin and absolutely uniform. Ask yourself this question. How could a craftsman pass a crude tool through that tiny neck, bend it inward, and grind the inside perfectly without seeing? And they did that 40,000 times with machine-like precision. The only answer satisfying both logic and physics is that they never carved them. They spun them. Imagine centrifugal casting technology. Instead of chiseling a hard stone block, the worker places a pliable stone paste. Uncured geopolymer mixture onto a vertical axis turntable. When the table spins at high speed, centrifugal force forces liquid matter outward, compressing it tightly against the mold walls. This is how modern centrifuges work, or even how we manufacture plastic pipes today. This process automatically creates perfect radial symmetry. It explains why these vases are incredibly balanced. They were born from physical rotation, not from human eye estimation. When looking at these 40,000 vases, you do not see an art collection, you see mass production ruins. This is proof this civilization possessed not just the chemistry to soften stone, but the mechanics to shape it with kinetic energy. They 3D printed with liquid stone millennia before we invented plastic. The final and most painful question is not how did they do it, but why did they stop? If Egyptians possessed this great stone casting technology, why don't we see geopolymer skyscrapers everywhere in the ancient world? Why did history turn the page to hammers, chisels, and misery? The answer lies in the crumbling ruins of later dynasties. Look at pyramids built just centuries after Giza, like Amenemhat III's pyramid. Today, they look like piles of melted mud. Why? Because their builders lost the formula. They tried to mimic the past shape but no longer held the essence of the technology. You are witnessing a catastrophe of lost collective knowledge. Geopolymer technology was not common knowledge, it was a state secret, held by a tiny elite of priests and royal architects, the state alchemists. When drought struck, when the Nile stopped rising, as the famine still recorded, and when social order collapsed in the first intermediate period, the chemical supply chain broke. No more Natron from the desert, no more organized large-scale mining. The formula holders died or scattered, taking secrets to the grave. Then, a new force emerged, the Iron Age. When humans invented harder metal tools, we became intellectually lazy. Why brew complex chemical reactions when you can use a sharp iron chisel to cut stone? We traded alchemical sophistication for mechanical brutality. We started fighting stone instead of cooperating with it. You realize an ironic historical truth. Progress is not a straight upward line. Sometimes we go backward. We forgot how to control matter at the atomic level and accepted an era lasting thousands of years of hard labor and nosy machinery. We, modern humans with cranes and diamond cutters, proudly look back and call them primitive. But the truth is, we are the ones trying to reinvent the wheel. Those cast stones still sit there, defiant against time, like black boxes of a civilization that reached the peak of material physics, then quietly sank into the shadows of oblivion, leaving us with questions that took 4,500 years to dare ask. We began this journey with a lie, that mountains move only by muscle. We end it with a humble truth, that true intelligence lies in understanding nature, not conquering it. The Great Pyramid of Giza is not just a tomb, it is a message frozen in stone. It whispers that humanity was once greater than we imagine. And technology is not always metal and circuits, sometimes it is mud, water, and the rearrangement of atoms. Perhaps the biggest lesson from Giza is not about the past, but about our future. When we dream of building on Mars, we will not bring stone from Earth. We will do exactly what the Egyptians did. Use local dust, local chemistry, and cast new civilizations. Impossibility is just a limit of our current imagination, and history, as we have just seen, is always ready to be written again.